It is amazing how many legacy, what we call big iron systems still exist within the federal government today, and quite frankly, within commercial as well. We're talking about things like Spark system, VAX, PDPs, lots and lots of old equipment, but they run just like an x86 platform, for example, like a Hewlett Packard enterprise server. They run the hardware layer, then they have an operating system that communicates with that hardware. Upon the operating system sits a data structure, and then, of course, the software and applications access that data structure, right? Databases, things of that nature, and provide services like HR or finance or things of that nature. All of these things reside within a legacy architecture, and there's still many, many, many of these systems throughout IT today. So with the legacy hardware listed there, illustrated there to the left, there are problems with this solution, right? With the legacy hardware security, because many of those systems, of course, granted, I don't know of any incidents where a VMS operating system has been hacked or a VAX has been hacked, but security can be enhanced through newer technology. Of course, replacing that aging hardware becomes a real challenge for an environment. Many environments have to go to eBay to buy equipment because it just isn't manufactured anymore. It's decades old. And of course, huge service contracts related to legacy hardware, that because the workforce that actually services that older hardware is retiring and no longer around. So this creates a real challenge for many IT environments. So imagine now taking this legacy hardware with its known challenges that we have listed here to the bottom of the screen, and let's add in some of the things that we can do. Imagine now a technology that we can take this legacy equipment, illustrated here on the left-hand side of the screen, with no operating system change, with no change to the data structure, and no need to rewrite the applications. Remember, for many federal and commercial organizations, rewriting those applications can be millions upon millions and take decades in some instances just to rewrite all of the legacy applications from a legacy OS, like for example, Spark Sun, into a Linux environment or a Windows environment. There's just lots of code that has to be rewritten. Imagine now taking a technology that you don't have to do any of those things in order to make this work on a different type of platform. So we see the legacy hardware sitting over on the side and all of these advantages to moving from that legacy hardware. Of course, more of the advantages towards the bottom of the screen and the challenges on the upper part of the screen. And now let's replace that with brand new, what I like to call refreshable. I don't even know if that's a word, but I like it anyways, because a lot of these legacy environments, they do not have refreshable architecture anymore. It's been gone for decades. The ship has already sailed. So they need to be able to refresh this hardware, and an x86 platform allows them to do that. What's really cool about this technology is here in the upper part of the screen. No operating system change, no data structure change, no need to rewrite the applications. Literally, it can be a restore from backup tape from the legacy to the new environment. And let's see how we actually can accomplish this miracle in migrating legacy to new hardware. So moving legacy hardware to a new hardware platform, it requires some technology in there. And two of those things we're going to really discuss here real quick. It's type 1 virtualization and hardware virtualization. Remember, type 1 virtualization allows us to communicate directly with the hardware. All right, so directly from the hypervisor down to the hardware. And so we're going to see things like Windows, VMware, for example, KVM, type 1 hypervisors providing type 1 virtualization. And then we load hardware virtualization software right on top of that type 1 virtualization. That allows us to create an environment that is truly a hardware emulation of that legacy environment. And that is why you see operating system, data structure, and software not change when you move from the legacy to the new architecture. There are many benefits to replace a legacy SparkVax PDP environment onto an x86 platform. And here are some of them. Just remember as we talk about these, no operating system change. Current data structure stays the same. No need to rewrite those applications. All of that stuff stays the same. Whether you're on legacy or x86, doesn't matter. Stays the same. In fact, restore from a tape and onto the x86 system. It'll work perfectly. So how does this happen? This happens because of that stack that you see there on the right-hand side of the screen. Of course, again, OS, data structure, software, remember, they're all staying the same, no change at all. What we are adding is that hardware virtualization layer, the type 1 virtualization that hardware virtualization software sits on. And again, that's all on an x86 platform. It enables our customers to replace this aging hardware that they just simply can't find parts for anymore. It allows them to reroute funds that they would use for expensive service contracts for that legacy hardware, enhances their security profile with newer technology found in x86, and again, a very aggressive return on investment. Many of these implementations taking what the customer spends on maintenance in a year pays for the solution. So usually an 18-month to 2-year return on investment. Great technology moving forward. Look for those aging systems within federal agencies and corporate America and see how they will migrate easily to the x86 platform.